Let's continue with our coin model. Now in this particular case, we're going to take k from 4 and bring it up to 16. And we'll see how that means we can now start leveraging some of the earlier techniques in our class for probability. So let's imagine first the sample space for the k equals 16 case. There are 2 to the 16th different possible outcomes, or sample points, which is 65,536, way too many to fit on the slide. So if we ask ourselves a question like, what's the chance we have 6 heads out of 16? We can't use that approach from before where we just visually figure out exactly how many there are. We can't just like write out the 65,536, circle the ones with 6 heads and proceed. It's just too many to list. So instead we're going to be a little more clever. So before we solve the 16th question, let's go back to the 4 coin question and think about how we could have solved that in a more scalable way. Okay. The first thing we did is we identified the probability of a 2 heads event, right? We know that all of those events have the same probability through symmetry if we think about the tree diagram. So any 2 heads event, whether it's heads, heads, tails, tails, heads, tails, heads, tails, and so forth, they all have the probability of 2/3 squared times 1/3 squared, which is 4/81. You're just thinking about any path through that tree that involved taking 2 tail lines and 2 head lines. Okay. The next thing we did is we figured out how many such outcomes there were because the probability of an event is just summing them up. And so rather than enumerating them, we can use the counting lecture. We can say, let's presuppose that we have 2 heads out of 4. And we just say, how many such outcomes are there? Okay. So we know that there's a total of 16 outcomes. So how many of them have 2 heads and 2 tails? Well, that's basically saying if we know that there's 2 heads out of 4, then there's 4 choose 2 ways to pick the position of those heads. Right? This is similar to our counting lecture before. So 4 choose 2 is just 6. So the overall probability is going to be 6 times 4/81 or 24/81. Okay. So that approach is going to work much better when we're doing 16 biased coins. So then what's the chance we have exactly 6 heads? Here's again where I encourage you to pause before I give you my solution. So there's 2 things you have to do. One is figure out what is the probability of any of those sample points. They're all going to have the same probability. The other one is how many of the sample points have exactly 6 heads. So first, the chance of any particular sample point with 6 heads, that's just going to be 1/3 to the 6th times 2/3 to the 10th. And the reason is you have to follow 6 heads lines and 10 tails lines. Okay. Next question, how many are there? Well, you have 16 things. You want to figure out how many possible ways are there to assign the positions of the 6 heads. That's just going to be 16 choose 6. Okay. So the chance of getting exactly 6 heads will just be the product of those 2 values. So it's 1/3 of the 6th times 2/3 of the 10th times 16 choose 6. Use a calculator or whatever, and you get some probability. Okay. Now some of you might have said, what if we choose the tails instead? Right? Like, couldn't we do like number of ways to choose the position of 10 out of 16 tails? And that also works. You could also write this as 1/3 to the 6th times 2/3 to the 10th times 16 choose 10. And that's just because of the fact that 16 choose 10 is the same thing as 16 choose 6. There's 8,008 of them. Okay. So that approach there, the counting lecture, is how we get to being able to solve this problem. And as we'll see, this kind of thinking is going to help us throughout all kinds of interesting probability problems as we move forwards. That is, the ability to count is fundamental to being able to compute probabilities.